आहे शॉर्ट आन्सर सेकंडचे आन्सर की हे 3 मार्क इचला असतात. फर्स्ट क्वेश्चन, क्लासिफाय अँड एक्सप्लेन द थर्मोडायनॅमिक्स. हॅलो फ्रेंड्स, कशा आहात? आज आपण महाराष्ट्र शासनाने शालेय शिक्षण क्रीडा विभागाने जी 2023 क्वेश्चन बँक पाठवली होती त्याची आज आन्सर की बघणार आहोत. आपले मागील काही व्हिडिओमध्ये थर्मोडायनॅमिकचे MCQ, शॉर्ट आन्सर, व्हेरी शॉर्ट आन्सर फर्स्ट, शॉर्ट आन्सर फर्स्ट अँड झाली होती कंप्लीट फिजिक्सची. आज आपण शॉर्ट आन्सर सेकंड बघणार आहोत. चला तर मग शॉर्ट आन्सर सेकंड बघूया. हे आहे थर्मोडायनॅमिकचे शॉर्ट आन्सर सेकंड. हे एकूण 12 क्वेश्चन्स आहेत. त्याचे आन्सर की आपण पुढील प्रमाणे PDF स्वरूपात बघूया. हे आहे शॉर्ट आन्सर सेकंडचे आन्सर की हे 3 मार्क इचला असतात. फर्स्ट क्वेश्चन, क्लासिफाय अँड एक्सप्लेन द थर्मोडायनॅमिक सिस्टीम. Answer: Thermodynamic system can be classified as an open, closed and isolated system on the basis of possible transfer of heat and matter to environment. First point आहे, an open system is system that freely allow the exchange of energy and matter with the environment. Second, a closed system does not allow the exchange of matter but allow the energy to be transferred. Third, an isolated system is completely isolated from its environment. Matter as well as heat cannot be exchanged with its environment. हा आपला क्वेश्चन नंबर फर्स्ट कंप्लीट झाला आहे. क्वेश्चन नंबर सेकंड, एक्सप्लेन गिवन केसेस रिलेटेड टू द एनर्जी ट्रान्सफर बिटवीन द सिस्टीम अँड सराउंडिंग. फर्स्ट, एनर्जी ट्रान्सफर Q is less than 0, energy transfer Q is greater than 0, and then energy transfer is Q is equal to 0. Answer: consider a system with the temperature Ts is kept in an environment of the temperature Te. Let Q be the energy transfer between the system and the environment. First, when the temperature of the system is less than that of environment, Ts is less than T, the energy flow into the system shown in figure. हे फिगर आहे. As a result, the system gain energy. Q is positive. Environment T, system Ts, Q is less than 0. Second diagram, when Ts is less than T, the system loses energy, that is energy flow from system into the environment as shown in figure B. In this case Q is negative. Third, for Ts is equal to T as shown in figure C, the system and the environment are in the thermal equilibrium and there is no transfer of energy, that is Q is equal to 0. हे डायग्राम आहे. इथे आपला क्वेश्चन नंबर सेकंड कंप्लीट झाला. Question number third, explain the different way through which internal energy of the system can be changed. Answer आहे first, internal energy of system can be changed by changing the temperature of the system. त्याच्यात ऑप्शन फर्स्ट A, if the system is placed in environment which is at a temperature lower than the system, that is Ts is less than Ta, the energy is transferred from the system to the environment cause decrease in the thermal energy of the system. B, if the system is placed in the environment which is at the temperature higher than system, that is T is less than Ts, the energy is transferred from the environment of the system causing the increasing the internal energy of the system. Third point, internal energy of the system can be changed by doing some work. यातला फर्स्ट पॉइंट ए when the some work is done on the system by the environment, the system gain the energy and its temperature increases causing increasing the internal energy. B, when some work is done by the system on the environment, the system loses the energy and its temperature decrease causing decrease in the internal energy. Question number 4. Write a note on thermodynamic equilibrium. Answer first. A system is said to be the thermodynamic equilibrium when the flow of three conditions of equilibrium are satisfied simultaneously: mechanical equilibrium, chemical equilibrium, and thermal equilibrium. सेकंड पॉइंट एक्सप्लेन केलेले आहेत मेकॅनिकल इक्विलिब्रियम केमिकल इक्विलिब्रियम थर्मल इक्विलिब्रियम. सेकंड मेकॅनिकल इक्विलिब्रियम. ऑप्शन ए, फॉर a system to be the mechanical equilibrium there should not be any unbalanced force acting within the system and between the system and its surrounding. Option B, also the pressure in the system should be same through the system and should not be changed with time. Third, chemical equilibrium. A, for a system to the chemical equilibrium, there should not no chemical reaction going on within the system. B, there is no transfer of matter from one part of the system to the other due to diffusion. C, a system to be the chemical equilibrium, it is a chemical composition has to be same throughout the and should not be changed with the time. Thermal equilibrium. For a system to be the in thermal equilibrium, the temperature of the system should be uniform throughout and it is should not change with time. A system when the thermal energy is decreased in the term of the state variables. इथे आपले क्वेश्चन 4 कंप्लीट झाले. 5. Explain in graphically. First, positive work with vary pressure. Second, negative work with varying pressure. And third, positive work at constant pressure. Answer first. PV diagram showing the positive work with varying pressure. Yeah, diagram. PV diagram. Second, PV diagram showing negative work with varying pressure. Third, PV diagram showing positive work at a constant pressure. X-axis is equal to V, Y-axis P. V1, V2 is the distance from the x-axis to the question number 6. Write a note on free expansions. Answer first. Free expansions are adiabatic expressions. Thus, there is no exchanges of heat between the system and its environment. Second, also there is no work done on the system or by the system. Q is equal to W is equal to 0, and according to the first law of thermodynamics, delta U is equal to 0. Third, for example, when a balloon refrigerated suddenly or the tire is suddenly punctured, the air inside reaches and out rapidly, but there is no displacement of piston or any other surface. Fourth, free expansion is different than other thermodynamic pressures process because it is an uncontrolled change. It is an instantaneous change, and it is a system is not in thermodynamic equilibrium. 5. Option 4. A free expansion cannot be plotted on a PV diagram. Only it is initial and the final state because plotted. Question number 7. 1 gram of water 1 centimeter cube because 1671 centimeters cube of heat at a pressure of 1 atmosphere. The latent heat of vaporizations at this pressure is 2256 joule per gram. Calculate the external work and the increase in internal energy. Solution. Numerical solution given m is equal to 1 gram, L is vaporization 2256 joule per gram, P is equal to 1.01 into 10 raised to 5 pascals, T is equal to 100 degrees Celsius, E is equal to 373 Kelvin, V steam is equal to 1671 centimeter cube, V liquid is equal to 1 centimeter cube, and delta V is equal to V steam minus V liquid 1671 minus 1670 centimeter cube. 1670 into 10 raised to minus 6 meter cube. To find first external work done by the system W. Second, increases initial energy delta U. From formulae, first I Q is equal to ml, second I W is equal to P delta V, third delta U is equal to Q minus W. Calculation आहे. From formula first, Q1 is equal to 1 into 2256 is equal to 2256 joule. From formula second, W is equal to 1.01 into 10 raised to 5 into 1670 into 10 raised to minus 6. Answer is equal to 1687 into 10 raised to minus 1 joule. Approximately 169 joule. From formula third, delta U is equal to 2256 minus 169 is equal to 2087 joule. Answer is from two word. First, external work done by the system is 169 joule. Third, increase in external energy is 2887 joule. Question number 8. Calculate the fall in temperature of helium initially at 50 degrees Celsius when it suddenly expands to 8 times its original volume. Gamma is equal to 5 by 3. Given Ti is equal to 15 degrees Celsius, 15 plus 273 is equal to 288 Kelvin. Gamma is equal to 5 by 3. V final is equal to 8 V initial. To find fall in temperature delta T, formula TF and Vf gamma minus 1 is equal to Ti Vi gamma minus 1. Calculation from formula TF is equal to Ti into bracket Vi Vf into bracket gamma minus 1 is equal to 288 into bracket 1 by 8 5 by 3 minus 1 288 into bracket 1 by 8 2 by 3 is equal to 288 into 1 by 4 is equal to 72k is equal to 72 minus 273 is equal to minus 201 degrees Celsius. delta t is equal to t final minus t initial is equal to minus 201 minus 15 is equal to minus 216 degrees Celsius. Answer: fall in the temperature delta T is minus 216 degree Celsius. Question number 9. A cylinder containing 1 gram molecule of the gas was compressed adiabatically until its temperature rose from 27 degrees Celsius to 97 degrees Celsius. Calculate the work done and heat produced in gas. Gamma is equal to 1.5. Solution: given n is equal to 1, gamma is equal to 1.5, T final minus T initial is equal to 97 minus 27 is equal to 70 degrees Celsius. We know R is equal to 8131 joule by mole K. To find first work done W, second heat produced Q. Formula: W is equal to NR into bracket TF minus TI divided by 1 minus gamma. Calculation formula: W is equal to 1 into 8.31 into 70 degree divided by 1 minus 1.5 is equal to minus 11.63 into 10 raised to 2 joule. As the work done on the system is converted into heat, rising temperature of the gas, heat produced Q is equal to 11.63 into 10 raised to 2 divided by 4.18 calories, approximately 278 calories. Answer: first work done is minus 11.63 into 10 raised to 2 joule. Second, heat produced in the gas 278 calories. Explain question number 7. Explain the Stirling cycle using diagram. ही स्टर्लिंग सायकलची PV डायग्राम आहे. The work substance can be air or helium or hydrogen or nitrogen. All processes are reversible. First of AB is isothermal expansion at temperature Ts, in which heat QH is absorbed from the source and useful work done in by the work substance. Second, BC is isochloric process in which some heat is released by the gas in bracket working substance to the refrigerator and the gas cool temperature Tc is greater than Th. Third, CD is isothermal compressions at a temperature Tc, in which heat Qc is rejected to the coolant sink. 4DA is isochloric process in which heat is taken in by the gas and its temperature rise to Th. Question number 8. Explain. First, working substance on heat engine. Second, hot and cold reversible of a heat engine. Cylinder of heat engine. The following part of the typical heat engine. First, a working substance. First point is a mixture of fuel, vapor and air. Gasoil oil means petrol engine or diesel engine. Second, the steam. In the steam engine, the working substance is called as system. Second, hot and cold reversible. The hot reversible is a source of heat that supplied heat to the working substance at constant temperature Th. The cold reservoir, also called the sink, that take the heat released by the working substance constant temperature Tc is greater than Th. Cylinder and pistons. The working substance enclosed in the cylinder fitted with a movable massless frictionless pistons. The wall of the cylinder and non-conducting but the base in conducting. The pistons monoconducting. The pistons is connected to a crankshaft so that the work done of the working substance mechanical energy can be transferred to the environment. Question number 9. State and explain the limitations of first law of thermodynamics. First, the first law of thermodynamics merely indicate that in any process there is a transformation between the various form of energy involved in the process, but provide no information regarding the feasibility of such a transformation. Second, first law does not provide any information regarding the direction a process will take place, whether it is a spontaneous or a non-spontaneous process. Third, practically it is not possible to convert the energy into an equivalent amount of work. No restrictions on the direction of the flow of heat. The first law of establish definition relationship between the heat absorptions and the work performed by system. The first law does not indicate whether heat can be flow from a cold to the hot end or not. For example, we cannot extract heat from the ice by cooling it to a low temperature. Some external work has to be done. व्हिडिओ आवडला असेल तर लाईक करा, शेअर करा, सबस्क्राईब करा आणि बेल आयकन दाबायला विसरू नका, कारण नवीन नवीन अपडेट आपल्या चॅनलवरती तुम्हाला मिळत राहतील. धन्यवाद.